This is question 38 on chemistry from the 2018 NSAA. So we're asked, for this following exothermic reaction, where we've got ethanol and ethanoic acid forming this ester and water, which of these changes will alter the position of the equilibrium? So we have increasing temperature by 25 degrees C, adding 20 centimeters cubed of water, adding a catalyst, and adding 0.5 moles of ethanol. So what's the rule of thermodynamics that we need to use here? That'll be Le Chatelier's principle. And what does that tell us about equilibria? That the equilibrium will shift to oppose the change that we impose on it. So for which of these changes do we think we can use Le Chatelier's principle? Now firstly, what about increasing the temperature? Well, we're told that the reaction is exothermic. So what's going to happen if we increase the temperature? Well, we know the reaction releases heat, so the equilibrium is going to shift to make the reaction cooler by shifting to the left. So we know that this is definitely going to alter the position of equilibrium. Next, we have adding some water. What's this going to do? Well, notice that water is one of our products. So what does this mean for Le Chatelier's principle? Well, if we're adding water, then the equilibrium is going to shift in the other direction, so to the left again, to remove some water. So we know this is going to change the equilibrium position. Then we have adding a catalyst. Now what's this going to do? Well, we need to remember that catalysts never alter the equilibrium position. All they do is speed up how fast equilibrium is reached. So they're going to affect each side equally, and the equilibrium is not going to shift to favour a particular side of the reaction. So this one is actually wrong. And finally, what's the effect of adding some ethanol? Well, similarly to part 2, notice that ethanol is one of the reactants. So what's going to happen if we add ethanol? The equilibrium is going to shift to the right to remove the extra ethanol that we've added. So again, this is going to shift the equilibrium position. And so our final answer is that 1, 2, and 4 are all going to affect the position. And so this corresponds in the question paper to answer C.